Good morning, Year 11s, and welcome to Lesson 3. What I'm going to do today is do a maths question with you. So it is using the surds and the rationalising the denominators and introducing it into fraction work that we need to make sure we remember our rules. So here's the question. If x is equal to the square root of 3 minus 1 all over the square root of 3 plus 1, find x squared plus 1 over x squared. Now, to simplify this down a little bit more, what I want to do is to do some pre-work and work out what my x squared is equal to. So what I'm going to do over here is I'm going to work out what x squared is equal to. We know that x was equal to that, so all I'm going to do is square it. So that just means I'm going to multiply by itself. So minus 3, put in brackets, and multiply it again by itself. Oops. Then I'm going to use my perfect square rule, which is going to be root 3 times root 3, which is 3. Root 3 times minus 1 is negative root 3. Minus root 3 plus 1 all over 3 plus root 3 plus root 3 plus 1. Now you could have used your perfect square rule. We've been practicing that a bit. Simplify this down to 3 plus 1, which is 4, minus 2 root 3 over 4 plus 2 root 3. Remember, with your working here is always to simplify as much as possible. What you can see here is there's a common factor. So I'm going to take the 2 out the front to give me 2 minus root 3 over 2 outside of 2 plus root 3. They cancel to give me 2 minus root 3 over 2 plus root 3. I am going to take it from that point and now put it back into my original question over here. So that's going to be x squared, which is what I have over there, 2 minus root 3 over 2 plus root 3, that's this, plus 1 over it, plus 1 all over 2 minus root 3 over 2 plus root 3. Remember, when I divide by a fraction, what I need to do is flip it and multiply. So I multiply by the reciprocal. So if I multiply that by 1, that's really simple. All I need to do is flip this fraction over. So 2 minus root 3 over 2 plus root 3 plus 2 plus root 3 over 2 minus root 3. Okay, there's a few different ways I can solve this. I could rationalise the denominator of both of those and then combine it, or I can then just combine it and do the adding of fractions. Now, when I add fractions together, I need a common denominator. First thing I'm going to do is put brackets around these. So my common denominator is found by multiplying these two together. So what I would have is 2 plus root 3 2 minus root 3 plus 2 plus root 3, 2 minus root 3. So that is my common denominator. Remember, whatever I do to the bottom, I have to do to the top. So I added 2 minus root 3 here, so I need to add that to the top. Did you see how I just put brackets around that original part and then multiplied it? The next one's the same. I then added 2 plus root 3 to the bottom of this, so I need to add that to the top. What I'm then going to do now is I now need to simplify this. This can all go over one set of brackets, 2 plus root 3, 2 minus root 3, and I'm going to then have 2 minus root 3, that's squared, plus 2 plus root 3 all squared. So this again is where I need to use my perfect square rule. So I'm going to square that, so that's going to be a squared, which is 4 minus 2 times 2 is 4 root 3, 4 root 3 plus 3. I'll do it again the next one. A squared, which is 4 plus 2ab, which is 2 times 2 is 4, plus that, which is plus 4 root 3 plus 3. All over a squared, but this is the difference of two squares, a squared minus b squared. Okay, you might find something is happening here. Minus 4 root 3 plus 4 root 3, they're going to cancel. 4 plus 3 is 7 plus 4 plus 3, so that is going to equal to 14. 4 minus 3 is 1. So we end up with actually a really nice answer, which is 14. There is some practice of those on page 26. It's at the bottom of page 7. Have a go at those and I'll do the next video.